So let us take up another problem to fit a binomial distribution. Already in the previous class we have studied how to fit a binomial distribution, isn't it? So let us fit one more problem. So here you can see 7 coins are tossed 128 times. Okay, so totally there are 7 coins. These 7 coins are tossed 128 times and the following distribution is obtained. So what is this? This is the observed set of values. Please notice here. So number of heads. When you toss 7 coins, what is the number of heads that are going to appear? There may be 0 heads, 1 head, 2 head, 3, 4, 5, 6 or 7 heads. Any of the heads can appear. And what is the observed frequencies of number of heads? So 7 times we have observed no heads. 7 times we have observed only 1 head. 20 times 2 heads. And 26 times 3 heads. So it has taken all these frequencies. What we need to do? We need to fit a binomial distribution. Okay, we need to fit a binomial distribution for these observed set of values, and later we need to obtain the theoretical frequencies. Now obtain madbekagutte. So how to start with this particular problem? So first of all, we need to define a random variable. Okay, so how to define a random variable? So let me consider x as a random variable. Okay, so here x is a random variable. So what does x indicate here? X indicates what? Number of heads. So it indicates number of heads obtained in a toss of 7 coins. So what is x? X indicates number of heads obtained when we toss 7 coins. So then x can take the value either 0, 1, 2, 3 or it can go up till 7. Okay. So x is a random variable. It can take value 0. What does x indicate? Number of heads. It can take value 0 or 1 or 2, 3, 4, 5, 6, 7. So then what is x? So x is a binomial variable with parameter n value 7, and what is the probability of success? P. We don't know. We need to find this. Okay. So we are not having any knowledge regarding what is the probability of success P. We need to find P. So how to estimate P? Here value of P can be estimated. Here P can be estimated. P can be estimated by finding mean. That is estimated. Ready na? Estimated by the given data. So we have been given the data. What is the data that is given? So we know x values. What are the x values? 0, 1, 2, 3, 4, 5, 6 followed by 7. These are the x values. And also we have observed the frequencies of number of heads. So what are the different observed frequencies? Let me copy that. So 7 for 0, again 7, next 20, 26 followed by 30, 21, 14 and 3. So these are the observed frequencies. Okay. So now what we need to come up with? We need to add one more row to this. Okay. What is this row? This is the x into f row. 0 into 7 is 0, 1 into 7 is 7, 40, here 3 2s, 6 3s are 18, 1, 2, 3, 6 78, next 4 3s are 12, 120, so 5 2s are 10, 105, 6 4s are 24, 6 1s are 6, 84, 7 3s are 21. Let me go with this value once again. So 0, 7, 40, 78, 120, 105, 84, 21, So these are the given values. Fine. Next, total. Let us total them, all these values. So the first frequency total, anyhow we know we have tossed how many 7 coins has been tossed 128 times. There is no what to say, we need not have to find it to find the total. Next one is next total. If you add all these values, the total will be 455 is the total. Okay. So by the given data, we can estimate the p value, that is probability of success value. How we can estimate the p value? By finding the mean. So what is mean? X bar is equivalent to summation fx by capital N. So what is summation f of x? So summation fx is 455 divided by 128. So the answer is 3.5547 is the x bar value. 3.5547 is the x bar value. Okay. Next, followed by this, how to find the p value? We know that in a binomial distribution, for a binomial, we know that mean is equivalent to x bar is equivalent to, what is mean of a binomial distribution? NP. What is x bar? Already we know the x bar is 3.5547 is equivalent to NP. What is N value? 7 into P. What is P then? So I will be writing here, P is equivalent to 3.5547 divided by 7. So we will be getting the answer as 0.51. So this is the value for P. Okay. So this is the value for P. So P is equivalent to 0.57. So now we came across the value of the parameter P, 0.51. Since we know the value of P, we can aramse say what is the value of Q. Q is equivalent to 1 minus P. Okay. That we can find it out later on, no problem. So next, just part of the work is over. Next, followed by this, we need to find the probability mass function followed by this. So the probability mass function PMF is probability of x is equal to NCx P power x Q power n minus x, where x can take value 0, 1, 2, dash dash n. This is the general PMF. But for our problem, n value is 7, 7cx. What is the parameter p value? 0.51 to the power x. What is q? Q is nothing but 1 minus p. What is q? Q is 1 minus p. That is 1 minus 0.51. What will be the answer? 0.49 will be the q value. Okay. So 0.49 to the power 7 minus x, where x can take value 0, 1, 2, dash dash up till 7. Okay, up till 7. So this is the customized version for our problem. Now let us find what is the probability of x taking the value 0. So that is 7c0, 0.51 to the power 0, 0.49 to the power 7 minus 0. 7c0 is 1 into anything to the power 0 is 1 into, we are left with 0.49 to the power 7. So 0.49 to the 7 will be yielding you the value 0.006782. Okay. So if you multiply this with 1, you are going to get 0.006782 as probability of x taking the value 0. Okay. Or else simply you can write it probability of 0. So probability of 0 is 0.00678. But we want to know what is the theoretical frequency of x taking the value 1. That is, t of x will be considering the value what? 0. So let me write like this. You can write it like this: t of x is equal to 0, or directly t of 0. So what is t of 0? T of 0 is equal to, there is a formula. Please let me write it once again. T of x is equal to n into probability of x. So what is t of 0? T of 0 is equivalent to, n value is 128 times. We are tossing 7 coins, totally 128 times, into what is p of 0? 0.006782. So if you multiply this value, you will be getting the answer 0.8681. It means we have tossed 7 coins, totally 128 times. Out of those many times of tosses, 0.8681 times there is a chance of getting 0 heads. So that there will be no value like 0.6881 heads. So we will be approximating it to 1. We will be approximating it to 1. It means out of 127, tossing 7 coins 128 times, there will be 1 time there will be no heads. Okay, that is the frequency of getting 0 head is 1. Now we need to continue it for other frequencies. So how to continue this? Please notice here. You will be using a particular formula. In the last video session I have told you, we will be using the recurrence relation. Okay. So by using the recurrence relation, by using the recurrence, RECURRANCE recurrence relation, we can obtain other frequencies. We can obtain other frequencies. Okay. So what are the different frequencies? Now I would like to know what is the frequency of getting only 1 head in 128 tosses. So T1 is equivalent to n into probability of, what is the frequency? So sorry, for general formula is, let me write the general formula. T of x is equivalent to n minus 1 plus x divided by x into p divided by q into t of x minus 1. This is the formula. If you are not using this, there is another version I have told you in the last video, that you can also, in case if I want to find t of 1, then I can use n into probability of 1. If I want to find t of 2, then I can use n into probability of 2. But it is a difficult process. If I want to find t of 7, then I have to use n into probability of 7. For every frequencies, I need to find their respective probabilities. It is a difficult procedure. That's why we will be using the recurrence relation. Please keep it in mind. Okay. So what is the general way now? So I need to find what is the frequency of getting only 1 head, that is t of 1 is equivalent to 7 minus 1 plus what is x value 1 divided by again 1 into what is the probability of success p value. It was 0.51. It was 0.51. Yes, 0.51 divided by q is 0.49 into t of x minus 1. T of x minus 1 is t of 1 minus 1, that is nothing but t of 0. The previous frequency is 0.8681. So if you work on this particular expression, the t of 1 value will be, you will be getting t of 1 as 6.3198. It means out tossing 7 coins 128 times, you will be getting 1 heads. How many times? You will be getting 1 heads 6.3198 times. So which can be approximated to 6. Okay. So out of 128 times tossing 7 coins, approximately you will be getting 6 times only one hit. Okay. Similarly, you will be finding the next frequency, that is T of 2. Okay. So, similarly T of 3, T of 4 and T of 5. So, I will be writing the final values. So, for T of 2 it is 19.7178, which can be approximated to 20. Okay, which can be approximated to 20. Next, T of 3 is equivalent to 34.1775, again which can be approximated to 34. Okay. Next, T of 4 is equivalent to frequency 35.5446, which can be approximated to 36. Similarly, T of 5 is equivalent to T of 5 is 22.1798, which can be approximated to 22. T of 6 is equivalent to 7.689, which can be approximated to 8. Last frequency T of 7 is equivalent to 1.1424, which can be approximated to 1. So, these are all the theoretical frequencies when you toss 7 coins 128 times. Okay. So, after finding all the frequencies, you need to plot once again a table describing the observed frequency as well as theoretical frequency. Let me do that. So, x, that is number of random variable taking the value 0, 1, 2, 3, 4, 5, followed by 6, and the last one is 7. Next, added to that we have certain observed frequencies. So, the observed frequencies are observed frequency, next followed by this theoretical frequency. So, what are the observed frequencies? 7, 20, 26, 30, 31, followed by 30, 21, not 31, 21, 14, finally 3. If you add all these observed frequencies, you will be getting 128. What about the theoretical frequencies? So, the theoretical frequencies are for 0 was 1, for 1 it is 6, for 2 it is 20, for 3 it is 34, for 4 it is 36, 5 it is 22, for 6 it is 8, for 7 it is 1. So, if you add all these values, you will be getting 128. Okay. So, by almost in this particular problem, the observed frequencies and theoretical frequencies are matching. Okay. Please go through this problem. This is an important problem for 10 marks. Thank you.